Hello, welcome to the Hidden Gems Screencast. My name is Arden Thomas. I'm the Syncom Smalltalk Product Manager. Any comments or suggestions you have on this, please send them to athomas@syncom.com. So recently we put together a brand new series called the Quick Start Guide. I wanted to build something fun and straightforward for someone who does not know Smalltalk that would show important Smalltalk principles and get them up to speed as quickly as possible. Now, it can even be for someone new to programming if they're patient. So what we came up with, I put together and the team produced this Quick Start Guide series. Here's the link to it if you want to go to it, or if you know someone who wants to learn Smalltalk, please send them to this link right here. And what it does, it takes them through the basics quickly, not a lot of wasted time at all. That's the essential idea of this. So what is object-oriented? A quick language primer on Smalltalk, installing the product, running Smalltalk expressions, something simple that introduces them to the tools and they build a customer class, and finally a series that takes them through building the 15 puzzle. Now, if you haven't seen the 15 puzzle, what it looks like is this, and the whole idea, you have one empty space, and the whole idea is to move the pieces around until you have them in order, 1 through 15, ascending order. It's a good example to build because it's a straightforward example that's straightforward and fun, and it shows some important principles like model view controller and other architectures that are important to Smalltalk. So the application itself only has these 4 classes. That's it. The application, the model, the puzzle piece, and the puzzle view. So let's take a quick walk through what that looks like. Okay, here's the 15 puzzle app. If I go to the initialize method, it will show me how this is put together. Okay, it has a model and a view. So let's take a look. We create the model and we tell the view its model is the 15 puzzle model. Then it can be automatically updated. Let's take a look at the model. The model's initialize keeps puzzle pieces, 15 puzzle pieces. Let's see what else we have. Well, we can get the puzzle pieces, all positions. So this is a 4x4 grid in which each position is a point with row and column. So we do 1 to 4 rows, 1 to 4 columns, and all positions, we add the row and column, so we have all 16 positions. Another important thing is, how do you find the empty position? Well, you get all the positions and you go through all the puzzle pieces. You remove each piece's position from all positions, and then the only one that's left is the empty position. The initialize simply gets the new puzzle pieces. And finally, the moves. So let's say move down. We find the empty position. Then we say move from the empty position minus, so remember it's row column. So it would say if the empty position is here, then -1 row would be right here. So we'd move this piece to the empty position. And that's basically the way. And here's the move from to. Simply says, let's get the move piece. And then we tell it the move piece, the position, from point to point, we get the move piece, which is the position, the puzzle piece at from point, and we change its position to the 2 point, and then we simply say the board is changed. self-change board. That will cause the view to redisplay itself, and we'll have the updated board. Puzzle piece. So we created puzzle pieces. That was right here. 15 puzzle piece, new puzzle pieces. The puzzle piece itself simply has a number and a position. So the number that's displayed and the position, which is a point that represents the row and the column. And if we go here, new puzzle pieces. So here we show basically the idea of a block, and it's going to be a random block. So we're going to create, we want these to be placed on the board in random order. So we get the numbers 1 through 15 in random order, and we basically create a random block. We ask the random block for its value, and we add it to the random sequence if it doesn't already exist. So if it already exists, we don't add it, and we keep getting random numbers until we have 1 through 15 in the sequence. And then we simply say to that sequence, let's create a 15 puzzle piece with that number in random order. And then we basically tell it its position, 1 through 4 rows, 1 through 4 columns. We get the next puzzle piece and we give it its position. Then we return the 15 puzzle pieces. So that is how it is created. Finally, let's take a look at the 15 puzzle view. Well, we get some information like the cell height, which is my bound height divided by the matrix size. It's 4, since it's 4 by 4. Integer divided by 1, that's my height, my width. Same basic idea. We get a font description and a font size. Since I want these numbers to be big, I'm using 70 here. Matrix size is 4. My width, self-bounds width. So let's do a display. Display on the graphics context. We set the graphics context font. We display the grid, then we display the puzzle pieces. Well, let's look at display the grid. We set the line width to 9. The rectangular border, we do basically a big rectangle to my bounds. We set the line width to 5. We go 1 to matrix size minus 1. And we display the line, matrix size minus 1. So we're going to do 1, 2, 3 lines and 1, 2, 3 lines. So the matrix size is 4. We want to display 3 lines like this, vertically and horizontally. And this does it right here, straightforward. Then display the puzzle pieces. Okay, a little more interesting, but still fairly compact. We get the puzzle pieces from the model. Then for each puzzle piece, we get the cell box for that puzzle piece. We change the paint to yellow. We inset 2 by 2, so the rectangle here, we inset it and we paint it yellow. Then we change the paint to black, and we display the number string at the centered plus an offset so the number displays properly. And how do we know that offset? Well, we get the width of the string that we're displaying. So a 9 will have a smaller width than 11, so we figure that out properly to center it properly. And that is basically it. That is the 15 puzzle. We can move all the pieces. And the one other piece, there is not a dedicated controller because this is pretty simple. So you may be saying, well, what acts on behalf of the controller? When we open the interface, we put in a keyboard hook and get the event that comes in. So if you're pressing the up arrow, it says self model, move up, move right, move down. and then return nil, which means that I've consumed that event. And of course, those correspond to the moves right here. Move down, move left, move right, all very simple and straightforward. And again, the move says self-changed board, which causes the view to display itself right here. Display the grid, display the puzzle pieces, and that works just fine. So again, this is a fun and shows a lot of the important principles. Model view controller, how to do displays, how to do a visual application, and all of it is compact, straightforward, 4 classes only for the whole thing. And so I'm hoping that developers new to Smalltalk find this a lot of fun and some great instruction, and also expose them to how great Smalltalk is, and some of the capabilities, like being able to go into the debugger and do things very, very rapidly and productively right there. Okay, if you have any comments, suggestions, please send them to myself, Arden Thomas, athomas@syncom.com. If you know anybody who might want to learn Smalltalk, please send them to this link. And until next time, have a great time with Syncom Smalltalk. Thank you.